Okay, let's have a look at square roots 236, which is down as a medium, so it might not be quite as trivial as last week's. So the first thing to look at is how many starting squares we've got. 7. These are the squiggled squares. And how many words we've got. 7. So each word must start in a different square. What else can we see? There aren't any starting squares that are vowels, the squares that are asterisked. So all the words start with consonants. That doesn't help us looking at where words start. But we do have a clue that only one of the words doesn't have a vowel as the second letter, which is Shilton. And in the grid, we can see that all of the starting cells have an adjacent vowel, except this top left-hand one here. So we know that that must be the start of Shilton. That must be the S of Shilton, because anywhere else, no other words can fit there, starting there, because they all have a vowel as the second letter. And then we need to get a third letter, needs to be the I, and the only vowel within that many letters is this one, I, so that must go S-H-I. So we've got S-H-I of Shilton in. As we've seen in the last couple of solutions, double vowels are very useful as a clue. We've only got one double vowel position in this puzzle, which is here. And we've only got one word with a double vowel, which is seaman. So we know that this must be the E and the A of seaman, but we don't know which way round it is yet, the E and the A. Let's think about how seaman could fit in using that E and A. Well, if the E and the A are this way round, it would have to either have the S there or there, and then the M would have to be there, because you can't have the N there because no words start with an N, so that starting cell would have to be an M, and the N would have to be here. How about if the E and the A were the other way round? Well, the S would have to go in its starting cell up there. Then the M, well, the M is the start of Martin as well, so it could go in a starting square or it could go over here. And then there are plenty of other vowels around for the second A and seaman, so we don't really know what to do after that. So how can we choose between the EA and the AE? Well, if we have the EA, we've filled in the starting square with the M. So, because we couldn't have the N there because it's not the start of a word. So that M must be the start of Martin. Martin has to use that A because there's no vowel, that other thing isn't a vowel. Then we've got nowhere for the R, so we can rule out this because Martin doesn't work. So we know the E and the A must be this way round. And we know the S is there. So that's filled in a bit more. Generally, we haven't got very many vowel positions in this puzzle, so maybe we should look at quite a long word that's got vowels in and try and fit that in. Which, the one to look at then is Benetti. Should have underlined my SEA of seaman. Looking at it in a bit of detail, I conclude that these have to be the O and the E of Benetti, because you can't start anywhere else and use the O and the E next to each other. For example, if you do B-O-N-E, then you're stuck for the rest of the word. You've got nowhere to go. This one's just a vowel on its own, too far away to do the O and the E. So, yeah, this has to be the O or the E, and the E or the O of Benetti. And then the B would have to go there or there. In either case, we've got to get from the, if we go B-O-N-E or B-O-N-E, we've then got to get over to this I using the double T. Well, the double T could go there, there, or there, there. So we know that's a T. So what have we filled in Benetti? Just one T. Thinking about what we've got left, these starting squares, and the words we've got left. Well, I'm going to take a bit of an educated guess here. There was no real logic, but looking at this ES, and the availability of this vowel, I thought probably James would fit nicely in here. So we can put James in with reasonable confidence. Let's come back to Bonetti here now and think about this bottom left starting square. Right, well that's got to be an O or E, so we need a word where the second letter is an O or an E. We know all the words apart from Shilton have the second letter as a vowel. Well, the only word with an O and E or an E as the second letter is Bonetti. So the only thing that can start bottom left is Bonetti. So we can now put the B in, and we can be sure that that's the O and that's the E. And then that means that to get from the O and the E, that has to be the N. We still don't know which way the T's go. So over on Bonetti, we've done the B-O-N-E-T and the I. We've also got Shilton partly in. We've got the S-H-I, and now we can notice we've got a T-O-N. So we've only got the L missing out of Shilton, which could go there or there. So interestingly, we've got a situation where either of those could be L and either of those could be T, so they're swappable. And this is a slightly convoluted clue. Now the puzzle must have a unique solution. So it means that another word must use either the L or the T that we haven't put in yet, or both of them could be in a different word. Well, the L is only in Shilton. There's no other words with L's in. So it must be the T that's used in another word. Well, it could be in Hart or Martin. And they're not going to get over to this square. So we can be confident that that's the L and that's the T. So we've now put all of Shilton in and all of Bonetti in. So we now know that either Hart or Martin or both of them must use that T to make the puzzle unique. So how could they go over there? Well, we've got A-R-T in both of them. That would work with either Hart or Martin starting in those. So that could be an H or an M. That could be an H or an M. And we know that square there is an R. So we've now got the art and art in. If that's going to be the T of Martin, it must go up there for the Y. So we've got the Y in. The N could be there or there. So let's think about these Hart and Martin starting squares. We've also got Seaman, which is S-E-A. It could go M-A-N, which can't work, so we need one for an H of Hart, one of these two. Or it could go M-A, something at N. So it can't go down there because it has to use that as the N then, and we need it for Hart. So that must be the M of Seaman, and that must be the A. And then we haven't got a starting square for that starts with an N, so that must go there. Right, so we've now got Marty, and we've got Hart in, and we've got the rest of Seaman in. Okay, so we're getting there. We haven't got Banks in at all, and there's only one starting cell left, so that must be the B of Banks. We've got a nice S available here, so that must be the K of Banks. And we've only got one square to go, and it's the end of Martin. Look, that hasn't been done yet, so let's put that in. And there we go, a square roots 236 medium done with almost entirely logic and only a bit of educated guessing. So that's not bad, is it? Now I did use my app along the way to do a bit of checking. I think I only made one silly move. I think I got a bit carried away with Seaman very early on and I didn't notice it could wander off this way. Thought it had to go backwards and forwards across here. And now we'll look at how many ways the words could fit in the grid according to my app. Just a quick screenshot in of that. Here are the numbers of ways written down, the total number of ways, ignoring whether it blocks any other words completely, and the number of ways once you've discounted ways that would block another word completely from the grid. So we can see that they all fit in quite a lot of ways. The least numbers are for Bonetti and Seaman with 10 different ways. Shilton fits in 33 different ways, but it was very useful that it had to start top left because that starting cell couldn't be used for any other word. Hope that was useful. Thanks for watching.